So we're talking about differentiability and continuity. Differentiability is the process of taking a derivative. The derivative is the limit of f of c plus h plus f of c over h as h approaches 0. And if this limit exists, we know that the derivative exists and the function is differentiable. If a function is not differentiable, it means the derivative does not exist. And what this means is that the limit from the left does not equal the limit from the right, so the derivative does not exist and the function is not differentiable. An example of this is the absolute value function. So for the absolute value function, the limit of f of c plus h plus f of c over h as h approaches 0 from the left is -1, and that's over here on the side of the graph. The limit of f of c plus h plus f of c over h as h approaches 0 from the right is 1, and that's over here on this side of the graph. So 1 does not equal -1, and that creates this corner here at c, where the derivatives don't equal. And anytime we see a corner like that, we know that the derivative from the left does not equal the derivative from the right, so the derivative does not exist, and the function is not differentiable there. Another time that a function is not differentiable is a vertical tangent. So on a graph we can see the vertical tangent where the slope goes straight up, but we can also see a vertical tangent through an equation. So the equation for this graph is f of x equals x to the 1/3. And to find the vertical tangent, we need to find f prime of x. So f prime of x equals 1/3 times the cubed root of x squared. And to find where this does not exist, we have to set the bottom of the fraction equal to 0. So when f prime of x does not exist is when 3 times the cubed root of x squared equals 0, and this happens when x equals 0. So we know there's a vertical tangent at 0, and that the function is not differentiable there. Another time that a function cannot be differentiable is a piecewise function. So an example of a piecewise function that is not differentiable is g of x. So for g of x, it's x when x is greater than 1, and that's right here. 0 when x equals 1, and negative x when x is less than 1. So to find where the function is not differentiable, we have to find g prime of x. So for g prime of x, it's 1 when x is greater than 1, and -1 when x is less than 1. And right here, where it's not continuous, the left and the right hand derivative don't equal, so we know that the function does not exist, and it's not differentiable at x equals 1. So now we need to tie continuity into differentiability. So we know that continuity is when the limit of f of x as x approaches c must equal f of c. And if this is true, you know that the graph is continuous. An example of a graph that is continuous is the absolute value function. So we know it's continuous because it follows this rule, and there's no holes, jumps, gaps, anything like that on the graph. But it's not differentiable right here. So we know that continuity doesn't guarantee differentiability. If we look at differentiability, the derivative is the limit of f of x plus h plus f of x over h as h approaches 0. And the existence of this limit implies that f of x exists, and that the limit of f of x as x approaches c does equal f of c, which is the rule of continuity. So if that's true, we know that the graph is continuous, so we can say that differentiability does guarantee continuity. So that's a summary of differentiability and continuity, and I hope that helped.